Hello, my lovelies! How is everyone doing today? I cannot do this. These will be too visually distracting for me, so I'll be right back. Haha, I am returned. Also, welcome, Andy. Congrats on the first message. What if instead of the network stack, I surprise you with a deep dive into a more delicious pancake stack? Maybe someday. I do think it would be quite fun to do a cooking stream on here. But I'd have to have a pretty serious change in my computer setup. I'm super excited about today. I actually feel pretty happy with my PowerPoint. I have fancy animations and shit. Hopefully they work. But yeah, I'm pretty excited. Today we are talking about the OSI model and how IP routing works. And yeah, I'm gonna get my thing to work. Oh, infinite. That's not what we want. Property. Haha. Okay. So y'all ready for some PowerPoint times? I sure am. Hey Marcy, welcome. How's your day going? Also, sadly no tea today. Oh no! Drop my glasses! I love having things on a glasses chain. It helps so much. Particularly when I forget to take them off when I'm cleaning. Alrighty. Yeah, let's get started. So, the OSI model and how IP routing works. Also currently taking name recommendations for our lovely weird cross between a whale and a boar, I think. I know. I figured. So, table of contents for today. We are going to be doing a quick review of Tuesday's lesson. Then we're going to be going over whale boar, pronounced Wilbur. Then we're going to be going over what a datagram is, since that's kind of basic term that's going to be thrown around a lot. Then we're going to be going over the OSI model, and assuming we have time, we're going to be going more in depth on the Internet Protocol v4. I know all the cool kids are switching over to v6, but v4 is still pretty thoroughly used, and the IP and the header is a little smaller, so we'll be going through that one. Dog is not liking the thunderstorm we have here. Aww, poor puppy. That's no fun. Alrighty. So, first thing from last lesson that we went over was the assumptions that were made in the Internet Protocol design. So, to reiterate those in human legible language, the assumptions that they made, slash the definition of scope for the design of the Internet Protocol was that, one, they are going to be reusing the existing network infrastructure that they had at the time. Two, that they were going to do packet switching, not circuit switching. This was primarily because ARPANET was already the biggest network and it used packet switching. That networks were going to be interconnected by packet switches, by gateways, and that all gateways that interconnected these networks would have a store and forward packet algorithm implemented. Any questions about those assumptions? They're kind of just the criteria that they were assessing their design on, or the base set of constraints they had to work with. Yeah, and again, ARPANET was already the biggest one, so they wanted to make sure they didn't have to change too much to ARPANET to get it to work with the rest of the internet. Will this be on the midterm? I hope to God that I don't write a midterm. Next, going over the goals of the IP protocol design. So these are the constraints. The goals were, number 1, to connect existing networks in a way that enabled multiple users to use the network simultaneously. 2, to ensure that a loss of networks or gateways didn't halt ongoing communications. Keep in mind that this internet protocol design was happening during the Cold War, and the main thought behind why DARPA was funding the design of this internet protocol was in the case of a nuclear attack. So if individual parts of the network going offline meant that communication got halted, that wouldn't be a great plan. Is there a face? Not an intentional face, I don't think, but I can kind of see a clown face there. Here's the nose. There's the eyes. Here's a big old mouth and the weird clown hair. No, just a mushroom cloud. It needed to be able to support multiple different kinds of communication services that had different priorities. So TCP versus UDP, any other kind of communication protocol that wound up popping up. As a reminder, TCP prioritizes having a solid connection and ensuring that every single packet arrives and that it arrives in order. UDP emphasizes speed, so allows for packets to get dropped. That it supports a variety of different networks so that it didn't limit the design of networks that were able to interface with this new internet. Funny observation, the UD in UDP in each one letter after the TC in TCP. I don't understand. Sorry. Permit a distributed management of resources, which clearly they succeeded in. We have multiple different internet service providers. Got it. Yeah, we have multiple different internet service providers in the United States and across the world. There isn't one centralized service that's responsible for managing flow throughout the internet. That it was cost effective, that it allowed new host attachment with low effort, so easy to attach to the internet, easy to add a new computer or a new network to the internet, and that resource use must be accountable/traceable. So these are the goals of the internet protocol design. And as a reminder, these were in order. These were the goals in the priority that they were in. So when they had to cut corners to make something higher up their work, for example, loss of networks or gateways cannot halt ongoing communications, that means that they didn't optimize it for traceability as much, which was priority level 8. Any questions about stuff from last lesson? Either the the assumptions made in IP design, or the goals of the Internet Protocol design. How accountable or traceable is Luna? Luna is not accountable to anything or anyone. I personally do not think that Luna is a cat. I think that she is a demon that had cat-like traits described to her at some point, and then, like, made her best effort attempt at embodying what a cat is like. This cat, you should hear this cat purr. She sounds like something that's like, you know, synthesizers and like the bubble sounds that synthesizers make, like piano synthesizers. If you put that sound like inside a cat body and had like, and therefore it was muffled, that's kind of what her purring sounds like. I love Luna. I just don't think she's a cat. And she doesn't look quite like a cat. Honestly, like, I'm showing you a nice picture of Luna. She looks like a medieval drawing of an animal. Alrighty, so on to our first new thing. What's a datagram? Datagram is a term that was coined by this dude who is on the camera. His name was Halvor Botherby. I believe he was French. The term was coined in 1972 as a combination of the word data and telegram. So, datagram. Bestiary image come to life. That is Luna. Yes, correct. She looks like a specific, I will pull up one of these days, I will pull up an example of the specific medieval cat drawing that she reminds me of. So datagram, the idea had been around for longer than that, but in 1972 they came up with the word. A datagram is the unit of information that is communicated in a packet switched network. If you recall, on Tuesday we talked a bit about circuit switched versus packet switched. We won't be talking about circuit switched anymore since the design of the internet went with the packet switched technology. So more like the US Postal Service, less like how phones work, a phone switchboard. But yeah, so datagram is the name for the unit of communication in a packet switched network. It provides connectionless communication because it contains information in the header that says, like, who it is going to, where it is coming from, maybe what order it's in, like which order in the series of packets being sent. He was Norway, likely Norwegian. Good to know. So not French, Norwegian man. And datagrams have a payload, so the actual data that is being transferred, and then a little header that allows it to move through the system. Yeah. Any questions here? I know we're kind of flying through these first couple slides. That's because we're going to be going over the OSI model in great depth. Cool. Alrighty. OSI model. While I was working on this PowerPoint, I came across a useful, what are those called? Like, the things that are like My Very Excellent Mother, makes delicious spaghetti. Not analogy. It's a phrase. Mnemonic. Yes, thank you. I found a useful mnemonic for remembering the OSI model, so I'm going to show it to you. Please do not tell the secret password to anyone. So physical layer is please, data link layer, do, network layer, not, transport layer, tell, session layer, secret, presentation layer, password, application layer, anyone. Please do not tell the secret password to anyone. Physical, data link, network, transport, session, presentation, application. Woo! So yeah, let's talk about the physical layer first. So the purpose of the physical layer of the OSI model, so as a reminder, the OSI model is the network stack. So all of the parts of all of the different functionality that needs to be in place for a user program on one computer to talk to another user program on another computer. That's what the OSI model is for. Is all of those various different layers of stuff that needs to work. So we're going to start at the bottom and we're going to work our way back up. So the physical layer. What the physical layer is the part of the network stack that defines the electrical specifications, the mechanical specifications, and the procedural specifications for activating, maintaining, deactivating the physical links between network devices. So what that means is that the physical layer is made out of nodes, it's made out of cables, it's made out of hardware components, it's made out of the literal physical hardware that makes up a network. There are a couple different kinds of cables that you'll hear people talk about a lot. You'll hear people talk about coax cables. You'll hear people talking about shielded versus unshielded cables. You'll hear people talking about Cat5 or Cat6 cables, which are various kinds of Ethernet cables. You'll hear people talking about fiber optic cables. And you'll also hear people talking about other forms of connection, such as radio waves. And the two protocols for that are Wi-Fi, which I believe is actually, Wi-Fi is not the name of the protocol. The protocol's name is 207.11, I think, but don't quote me on that. 208.11, something like that. And then Bluetooth is the other major one that you'll hear about. Relevant protocols to know about at the physical layer are Ethernet, USB, DSL, Bluetooth. The protocols at those levels and specifications at those levels tend to have to do with like the maximum length of cable that's allowed and the materials that it's made out of. And that kind of stuff. What's being sent through it? So, like, is light being sent through it? Is it an electrical signal? Is it a radio wave? What speed is it being sent at? Is it 2.5 gigahertz or 5 gig? Is it 2.5 gigahertz or 5 gigahertz? All those kinds of things. So, that's the physical layer. And the way that you would debug a problem happening at the physical layer is, this is the, did you try turning it off and on again? Or the, is it unplugged? Did you check that it's plugged in? So when you're debugging something at the physical layer, you make sure it's getting power. You check to see if the cables have been damaged, if any squirrels have chewed on things, if your Ethernet cable has started fraying. You check to see if your connectors are damaged. So again, is it actually plugging in properly? Or is maybe there another hardware problem? has a circuit blown or something somewhere in the network. So that is the physical layer. Uh-huh. Any questions on the physical layer? It's pretty straightforward. And we may go more in depth on particular protocols if we feel like it in the future. Next up, we've got the data link layer. So the data link layer is all about how data is formatted for transmission. Now, if you'll remember from what we briefly talked about on Tuesday, the network layer is media ambivalent. It doesn't care if you're sending something through Ethernet or if you're sending it through Wi-Fi, etc. And so what the data link layer does is it basically translates from the network layer down to the physical layer to make sure that the formatting of the message is appropriate for whatever the physical medium that the data is being sent through is. So the data link layer handles how the data is formatted for transmission. It handles how much data can flow between nodes. So it handles speed and throughput. It handles like how long the data is able to be in transit. And it also defines what to do if there are errors. So if like the data gets corrupted in transit, what do we do? Do we just throw it out? Do we ask for a new copy? Do we hold on to it and report it somewhere? However you want to do error handling, that happens at the data link level when there's corruption in transmission. The two major subparts, the sublayers of this weird layer, are the media access control and the logical link control. So if you ever heard of a MAC address, every single device that you own, every single like electronic device that can connect to the internet that you own has a MAC address, whether it's your smart scale, whether it's your phone, whether it's your computer. And that MAC address is assigned when the device is manufactured. It will always be the same for your device for the entire life of your device. And that address is stored in a thing called a network interface card, or a NIC. And in the data link layer, you have switches that are keeping track of all of the MAC addresses on a network. This is a task that's kind of shared in between the network layer and the data link layer, because what's happening here is that the MAC address is being mapped to an IP address. The IP address for your device can change. The MAC address cannot. And so because IP addresses don't really exist at the data link level, we can't like fully have media access control be entirely in the data link layer. It's kind of a shared task between the network layer and the data link layer, which is why in the 4-layer model, the network layer and the data link layer the data link layer goes away because it's kind of a weird half in between place. But yeah, so data link layer is responsible for keeping track of all of the various different MAC addresses, all of the various different devices that are connected to a particular network. Does that make sense? Also, please feel free to interrupt me, ask questions. I'll do elaborations as desired, all that fun stuff. Okay, yeah. And then the logical link control. This is the other half of what the data link layer is responsible for, which is it handles framing addressing. So what happens as you are sending a piece of information through the network is at each layer, starting with the application layer and moving down through the stack, it kind of just gets like wrapped up in another set of headers and information. And at the data link layer, it sometimes needs to split up that big package of information so that it can fit through the hole it's being sent through, right? You can only send so many pieces of data at once over a physical wire. There is a maximum size that you can send. And so the data link layer is responsible for chopping up that message and sending it through the hole bit by bit by bit. And the way that it deals with this is what it'll do is it'll make a header and it will make a trailer. And so what it'll do is it'll have a checksum. It'll have some sort of way to verify that the payload that was sent from the source is the payload that was received at the end. And it will have that information in both it'll have that checksum kind of thing in both the header and in the trailer. And then you can compare them and see if they work out. There are two different main methods of creating this verification called CRC and FCS, which we'll go into more in depth when we talk about the data link layer more in depth. Yeah, basically what the data link layer is responsible for, just to re-summarize, is in the first part, it's responsible for keeping track of all of the MAC addresses on a particular network. And then separately from that, as far as what it has to do with individual messages that are getting sent through the pipeline, it's responsible for handling the throughput of the network. So splitting it up into little chunks, sending it through, and making sure that the data that gets pushed into the pipe, making sure to check that the data that gets pushed into the pipe is the data that's coming out the other end of the pipe. So, yeah. Woo. To debug something at the data link layer, you have to first check all of your physical layer problems because it might be there first. Check to make sure everything's plugged in. Then what you would do is check, hey, are these nodes, if you've already verified that all of the physical stuff is wired together properly, are the two nodes failing to connect? Are they connecting and then randomly dropping? Or maybe are there a large number of transmission errors being reported? Are you throwing out a lot of packets that are being received? Those are all examples of issues that would be happening at the data link layer. Next up, we've got the network layer. So this is the one where we're going to be spending the most time over the course of this course. We're going to be spending the most time at the network level and up, but mostly at the network level and the transport layer. The network layer and the transport layer. So the network layer is responsible for sending information between and across networks through routers. It is basically, we've gotten to a point where we're not actually thinking about individual nodes anymore. That's a data link layer problem. We're thinking about network to network level. Network layer is responsible for sending information between and across networks through the use of routers. It's, handles connecting to your internet service providers so that your internet service provider can route you. It's responsible for tracking what devices are on the network. So remember what I said about how the data link layer and the network layer kind of overlap in this task. That's because of this bullet point, which we'll go into a bit more in detail on the next slide. It's responsible for tracking what other networks the network is connected to, and what paths are available for routing packets across the network. And those last two tasks are mostly accomplished by a thing called a routing table, which is kind of like a cache. It's like an easy place that is stored on your router to look up how to get to nodes that you visit frequently, how to get to various places on the internet that you visit frequently. So that's the network layer. And there's a lot more complicated things that can happen there. But that's it put simply. I'm going to slide over here just a second so that I can pull up. Okay, I guess it's not going to let me do that. So we're going to grab this one, slide it up here so that I can have this. We'll restart the slideshow. BGP, Border Gateway Protocol. The Border Gateway Protocol is a standardized exterior gateway protocol designed to exchange routing and reachability information among autonomous systems on the internet. BGP is classified as a path vector routing protocol, and it makes routing decisions based on paths, network policies, or rule sets configured by a network administrator. Sketched out in 1989. On the back of 3 ketchup-stained napkins, and is still known as the 3-napkin protocol. So what's kind of fun is BGP, I believe, BGP was the first network protocol that was implemented, not the first, but the paper that we were talking about on Tuesday, this design philosophy for the DARPA Internet Protocol, one of the things that it talks about as a failing of the Internet Protocol that they hoped would be the failing of the current design of the Internet and something that they thought would be addressed in next iterations was the fact that all routing tables had to be created manually at the point in time when this paper was published. This paper was published in 1985. And in fact, that did happen. BGP, the Border Gateway Protocol, or the 3-napkin protocol, was that. It is a protocol that is designed to exchange routing information. So that an individual person doesn't have to be typing in all of the things. Yeah, back when you could count this number of separate networks on your fingers and toes. Not so much now. Not so much now. We have far too many networks to be able to count all of them. Yeah, and here's the also involved in. The network layer is involved in, as I mentioned, tracking what devices are on the network, which means that it is involved in resolving MAC addresses with the node's corresponding IP address. This is called, the protocol used to do this is called ARP. Officially, if you're using the OSI model, this is a part of the data link layer, but because it's resolving IP address to MAC address, IP addresses don't exist at the data link level, so at the data link layer, so network layer is kind of involved too. How to debug things that are going wrong on the network layer. Check the physical and data link layers first. Then you're probably going to check to see if your IP address is incorrectly configured. Then you're going to check to see if there's a bad router somewhere en route between your source and destination. And the tools that you start having fun tools that you can use from the command line to debug. And some of those tools we've already used here before, but those are going to be ping, traceroute, ipconfig, nmap, netstat are all tools that you can use to debug or investigate the network layer. Word of caution, don't just be randomly nmapping things that are out there on the net. Some people interpret that as you trying to hack them, and sometimes governments agree with them, particularly Finland. Finland has stated that the use of nmap against someone else's system or router indicates an intent to hack. So maybe steer clear of that particular network investigation tool. Okay. And yeah, that's the network layer. So on to the transport layer. So the transport layer defines how two nodes are connecting. So how your source and your destination are connecting. And it also defines how the data packets are going to be broken up and sent over the network. This probably sounds a little confusing since I said that that's what the, that I said something similar happens in the transport layer. Or something similar happens in the data link layer. It is different what is going on here in the transport layer. What's going on here in the transport layer is that you're taking that initial message from the application layer and you're chopping it up into chunk-sized pieces for the purpose of making nice-sized little envelopes. What you're doing at the data link level is you are cutting it up even smaller, specifically based on the physical media that you are moving things through. The transport layer isn't doing that kind of optimization. It's just making things, rather than having a 300-page essay that you're sending, you're going to send it one page at a time. It's making it a more convenient size. So, transport layer. The specifics of how two nodes are connecting, and defining how the data packets will be broken up and sent over the network. By the specifics of how two nodes are connecting, what I mean is saying whether you want a connection or a connectionless connection between your two nodes. So if you're using TCP or UDP. TCP is the protocol that was first in mind when we were designing the internet. And it is a protocol that prioritizes data quality over speed. It is a connection-focused protocol, and establishes a connection with the destination node via something called a triple handshake, which we will go more into depth on how that works. But basically, TCP ensures, hey, I want to talk to you. Are you listening? Yes, I'm definitely listening. Okay, I'm going to start sending you stuff. And then it wants confirmation that messages were received. So you throw the first ball and you wait for a message back from your destination saying, yep, I got it. And then you send the next one. It's a very simple way to put it. And TCP, because it cares so much about the data quality, that there's nothing missing, that nothing's coming out of order, it guarantees that packets are going to be read in order at the destination, and that any dropped packets get resent. Dropped packet means a packet that got lost in transit. That's very different than UDP, which prioritizes speed over data quality. This is something that you're going to use probably for like VoIP, voice over internet, or to stream videos, to play multiplayer video games. Those sorts of things are going to use UDP. And that's because what UDP does is it's as close to just sending a raw datagram as possible, basically. It just lobs the packets into the network as quickly as it possibly can. And if at the other end it receives them a little out of order, having one out of order frame in a video isn't going to make a big difference. What is going to make a big difference is if you have to wait for that one frame that would have been shown out of order, if you have to wait for it to show up at your network. Because that's going to make the video stuttery, and you don't want that. So that's the major decision at the transport layer is, do we want to talk in UDP or in TCP? Which is, do we care about speed or do we care about quality of information? As far as debugging stuff at the transport layer, as always, you check your stuff that's lower on the network stack first. And then you're going to start checking your firewall or your access control list. A firewall or an access control list is a process that's running on your router that is looking for particular kinds of communication. So things that say, hey, I'm a TCP communication, or things that say, hey, I'm a UDP communication. TCP communications typically come through a specific port, through a particular mailbox on your router. And UDP communications also come through a particular port on your router, through a particular mailbox. And so some firewalls will have special rules that say, hey, I don't want anybody sending mail to this particular mailbox. I don't want anyone sending I don't want any incoming TCP mail unless it's from this white list of people, unless it's from this particular set of IP addresses. I don't want it. So if a message isn't going through and there's no other problem lower in the stack, it's probably going to be a firewall issue. You're probably getting blocked. Your message is probably getting blocked. Another potential source of error that happens at the transport layer is routers have a thing called a quality of service setting. These can be kind of funky if they're poorly configured, but basically you can tell your individual router to prioritize certain kinds of information. Hey, Analog, welcome to chat. you can tell your router to prioritize sending things like stuff from Netflix. You can tell your router to say, hey, anything that's from Netflix, please pass that along to the head of the queue. Please send that into my network more quickly. Or you might have something set to where it says, like BitTorrent, for example. Maybe BitTorrent gets deprioritized on your router. So if there's other incoming packages, BitTorrent gets continually pushed to the back of the line because it can wait. It doesn't matter how fast those messages come through. But if BitTorrent is being continually pushed to the back, it's never going to finish. So that's another place where the transport layer can go wrong, is if your router has a funky quality of service setting. But by and large, if it is a transport layer issue, it's going to be a firewall or access control list issue. Yeah, welcome, Analog. We are about 52 minutes in, but this whole thing will be up on YouTube, and I'll be providing the slides over on my Patreon. I'm actually proud of these slides because I did fancy things. And to debug the transport layer, you can use similar tools that you used over in the network layer. So you can use ping, traceroute, ipconfig, nmap, whois, netstat. All those same tools are going to be useful in debugging the transport layer. Any questions here? Dig. Yes. Dig is another good one. Oh, that's not what I wanted. I said another one that wasn't on here. Whois? Finger, if you're like doing something weird and old. Been trying to get your SSL certs working again. Fun! Any particular issues that you've been running into with it? Next up, we've got the session layer. So the session layer is responsible. So if the transport layer was responsible for deciding method of communication between two devices, the session layer is responsible for establishing and maintaining connections between two user applications on those devices. You're no longer dealing with individual devices at the session layer. You're dealing with the actual applications that are sending stuff to each other. Session layer handles establishing, maintaining, and terminating sessions between two specific end user applications. So at the session layer, you've totally lost the idea that signal might drop sometimes, or that packets might be lost. As far as the session layer is concerned, that session is like a guaranteed continuous thing. Is the goal. If things are working properly, session is continuous, and dropped packets are not perceived by the session layer. Analog says, certbot doesn't like your DNS provider. Oof, that's no fun. I'm sorry. There are, regarding the session layer, there are two main models of like ways that sessions are established and maintained. And those are a client and server model and a request and response model. So a client and server model is going to be you'll sometimes hear these called, like, nobody really calls them this, but like a push model versus a ping model. So with a client and server model, what's going to happen is you're going to have an application on one machine that is needing information. And then you're going to have a server on another machine that has the information and it's going to send it back. Is loosely what you'll think of it as. And so what'll happen is the client will say, "Hey, I want a thing," and then the server will, when it's ready to process that request and when it has that information, it'll send it back and say, "Hey, here's your thing." Whereas with a request and response model, what's going to happen is once the connection is established, there's going to be pretty much continuous back and forth saying, "Hey, do you have that thing for me? Hey, do you have that thing for me? Hey, do you have that thing for me? No, I don't have it. Hey, do you have that thing for me? No, I don't have it. Hey, do you have that thing for me? Yep, here it is." And then, session maybe ends. So those are the two models, very simply put, as far as design of different protocols in the session layer. There are a lot of different protocols that exist at the session layer, but a couple that you have probably heard of are the Network Basic Input-Output System, also known as NetBIOS, the Remote Procedure Call, RPC, Password Authentication Protocol, PAP, and Short Message Peer-to-Peer, SMPP, which, fun fact, I believe that SMPP is governed by the same body that governs SMS. Don't quote me on that, but it was at some point. And yeah, there are a bunch of protocols here at the session layer. So, debugging things. Debugging at the session layer, as always, you're going to check the lower layers first, make sure everything's plugged in, make sure that your network is actually connected up and working properly, that messages are getting received, and that messages are actually getting sent. Then what you're going to do is you're going to check to see if that server running on your destination is actually available. If that server is up and running, or maybe it's down, or maybe it's not receiving requests right now. Check to see if the servers are incorrectly configured. Woo! Congratulations! We love it! Is that the right one? Hooray? Nope. Sorry. I can't remember my own commands. What are they? Celebrate. There we go. Oh. I forgot that happens. We gotta fix that. Go away. Yeah, and has the session maybe timed out? Do you need to restart the session? Next, we've got the presentation layer. Don't worry, y'all. We're in throwing distance of being done with the OSI model. There are too many layers. Give me my 4 layers back. 7 layers is too much. So at the presentation layer, this is what handles encryption, basically. So this is another layer that we're going to be putting a lot of focus on. Main layers that we're going to be focusing on as we're looking at security stuff are transport layer, network layer, and presentation layer. Though there are a couple of cool exploits that you can do at the data link layer, fun fact. But we probably will not get into those too much in detail. So, presentation layer. This is what handles character encoding and decoding, and also handles data formatting and encryption. So for the data, for the character encoding and decoding, that's going to be, are you using ASCII? Are you using Unicode? Which are just standard ways of like encoding letters. So turning letters and emojis and all those kinds of things into bits. How are you doing that? That gets handled at the presentation layer. And then data encryption. So SSL or TLS is also handled at the presentation layer. Debugging at the presentation layer is going to be check the other things first, as always. And then, are you missing drivers? So a driver is a thing on a device, is a thing on your computer that provides those translations. So it tells you, like a driver for your printer is going to provide the translation for how your computer should talk to your printer. Drivers are basically translation dictionaries. Is a good way to think about them. But yeah, debugging at the presentation layer is going to be check to see if you're missing drivers, check to see if your drivers are maybe corrupted, or potentially you're trying to do something, like you're trying to send a message that you don't have permission to do. Maybe you're trying to use a tool that you don't have permission to do. Maybe you're trying to decrypt something that you don't have permission to do. So maybe you need elevated privileges on your machine to use SSL or TLS. And last but not least, we've got the application layer. Woo! So the application layer handles the services used by end user applications. The application layer is not necessarily literally every aspect of the application that you are using, of the application. It's not going to be Slack. It's going to be the services that Slack needs to be able to use to talk to the network. So that's going to be the Simple Mail Transfer Protocol, SMTP, which is how you send email. That's going to be File Transfer Protocol, which is how you send files. HTTP is going to be at the application layer, which is how you use web browsers. Domain name service is going to be handled at the application layer. Domain name service is the thing that lets you type in a URL that is human readable, rather than having to type in an IP address to go to a particular website. And SSH is also going to be at the application layer. So that's the thing that lets you open a secure shell on another computer over a network. And that's the application layer. To debug the application layer, you're going to check all of the stuff further down on the stack. Make sure your computer's plugged in. Make sure your network is connected. Make sure that you have the right permissions. All that fun stuff. Then you're going to check, hey, is my software application misconfigured? Is it actually set to use the right things? Does it actually know where to look on my computer to use things? And then always PEBMAC. Is there a problem between the monitor and the chair? I've heard both. I've heard picnic, and PEBMAC. And with that, that's OSI. That's the OSI stack, folks. Woo! We did it! So any questions? Any parts of the stack you want me to revisit? If there are, feel free to send a message now, or I will be uploading this to YouTube. So if you're watching this on YouTube, put a comment below. And yeah, how do you debug the PebMac layer? Carefully and with grace and kindness. My dad had a story about when he worked for one of the big companies in IT support. And the day that he decided that he needed to get out of the particular tier of IT support that he was in was, it was the early 2000s, y'all. So, like, don't judge the man on the phone too hard. But my dad was fielding a phone call, and the guy needed to access, like, Internet Explorer or something, and he couldn't find it. And so my dad was like, okay, take your mouse and move it to the bottom left-hand corner of your screen and click on the Start Menu button. And my dad hears this faint clinking over the phone line. And the guy says, I'm clicking on it and it's not working. And my dad responds, sir, are you clicking on with your mouse on the bottom left-hand corner of the screen? And the guy says, yes, I am, and it's not working. And the clinking gets louder. My dad says, sir, are you literally picking up your mouse and hitting it against the bottom left-hand corner of your monitor? And the guy says, yes, and it's not working. And my dad passed off the phone to someone else. Because he just couldn't. He had hit a point where he could not use language that was accessible to people who didn't understand computers at all. Why are we flooding? That's a great question. I missed this. Why are we flooding Finland? Why is Finland being flooded? XKCD comic. Let's do it. Don't mind my bad graphics. Okay. Tech support. Restart my computer? I know you have a script to follow, but the uplink light on the modem is going off every few hours. The problem is between your office and the modem. My computer has nothing to do with... Okay, whatever. I restarted my computer. It's still down, and even if it comes back, it's going to die again in a few hours because I don't have a start menu. This is a Haiku install, but that's not Haiku? It's an experimental OS that never mind. I'm sorry, but this won't get fixed until I talk to an engineer. Can you look around for someone who's wearing cargo pants? Maybe a subway map on their wall. There's a chick 2 phones over with a stuffed penguin doll and some posters of a bearded dude with swords. Perfect. Can you put her on? Sure. Hey, I'm so sorry to bother you, but my connection... Yeah, I see it. Lingering problems from a server move. Should be fixed now. Thank you so much. No problem. Hey, in the future, if you're on any tech support call, you can say the code word shibboleth at any point, and you'll be automatically transferred to someone who knows a minimum of 2 programming languages. Seriously? Yep. It's a backdoor put in by geeks who built these phone support systems back in the 1990s. Don't tell anyone. Oh my god. This is the greatest. Damn it. The fun thing is that what this dude is doing at the beginning is my version of Shibboleth. I've done this, again, learned this from my dad, but there's a certain set of, like, vocab words that if you drop them fast enough, early enough in the conversation, they just escalate you. As long as you're nice and friendly, as long as you're, like, very apologetic and you explain, and you start by saying, hey, these are the steps that I've run through so far. This is what I've diagnosed I think the problem is. They'll escalate you. Has been my experience. I've had issues with Xfinity in the recent past, just because their phone tree does not let you get to a human being anymore without them seeing that you've tried to restart your modem and that you've waited at least 10 minutes, which is awful and annoying. But if you can get to a person, if you know your shit, they'll get you to a person who can help you real quickly. You're from Finland, and with 180 lakes, you don't need to be flooded. Sin flood attack. A sin flood is a form of a denial of service attack on data communications, in which an attacker rapidly initiates a connection to a server without finalizing the connection. The server has to spend resources waiting for half-opened connections, which can consume enough resources to make the system unresponsive to legitimate traffic. I'm going to guess that the reason that What If Andy was suggesting a flood of Finland is because earlier I mentioned that Finland the government of Finland, not the government, the courts of Finland have previously, domain name server is what DNS stands for. Nmap has been used in a court case as evidence. The use of Nmap has been used as evidence of intent to hack. There was a guy who ran an Nmap against a bank's router, and the court system said, hey, that means that you were hacking, you were doing a bad illegal thing, and using Nmap against other people's servers is a bad illegal thing, which I think is a little silly, but I can kind of understand. But anywho, too many data lakes. Yeah, that's the fun, cool stuff. Since we have a bit of spare time, do y'all want to see something that I was working on yesterday? I've been working on a really shitty Python script. Here, let me pull it up. To automatically create my little schedules. So for those of y'all who have not yet seen my little schedules, give me 1 second. Did I ever finish my tweet leader? No, I did not. I did not. I know, I'm awful. Part of the problem is that I didn't actually really use Twitter, and so I had very little motivation to continue doing it when I got stuck on something stupid. I have continued working on a, thank you for the follow, Haka. But I have been working on a different Twitter thing, which scrapes Twitter without using any of the which scrapes tweets without using the Twitter API. Love shitty Python scripts. You have an unfinished metronome and an unfinished bingo bot and an unfinished... Oh, yeah. Me too, friend. Ah, shit. I did the bad thing again. Forgot that I need to zoom in, which OBS handles weirdly. There we go.
Old lady voice. My voice is already too croaky today for an old lady voice, but I'll do my best. Hello. I'm elderly. Can you tell?
Okay. And then I'll switch that. In big in terminal emulator font. Yeah. So this is my shitty Python program that I've been working on. Now we need to redeem a where you explain modern things in old-timey terms. Like what? And how old-timey? This sounds like a very fun puzzle. I would enjoy this. But I think I would need stricter definition of what this means. So this is my shitty Python script. The purpose of it is to, group parachute. Cue drop. Everybody join. We're gonna do a race. Oh no, I fucked up. Oh wait, maybe I didn't. Everybody join the race. Ooh, we got an octopus. We got anybody else joining? We're gonna start the race in 20, 19, 18, 17, 16, 15, 14, 13, 12. I remembered the number 12. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And the race begins! What If Andy starts with an aggressive move, bumping everyone out of the way. Marcy is removing Lesbian from the running, and we've got a winner with the close follow-up of Andy. Marcy, congratulations on the leaf pile. You have succeeded. I'm off in the corner. You like my my sports announcements? Welcome, Hacko! This is a regular occurrence here. I hope you don't mind. We will remember this. Well, you didn't even have to redeem a radio voice. I just slip straight into radio voice whenever we're doing a sports announcement. But yeah, this is my shitty thing to make my calendars. Right now, what happens whenever I'm making a calendar is here, moving things around. Oh, this isn't gonna work. Damn it. Right now, what happens whenever I'm trying to make a new calendar is I write out a giant list over in, here, I'll grab one of these. In a, in a spreadsheet. And, please. I'll write out a list of everything in a spreadsheet, And then I use that to create these little graphics by hand. So I'll make like one for about a month. And then I'll make one for each week. And so I'm making this script to automate that process, to automatically generate those, so that there are like 6 graphics a month that I don't have to make, so that I can instead focus on making stupid shitposty graphics, like my Snow Crash graphics, or things with techno wizards and dumb quotes that I can share on Tumblr. So yeah, I'm excited. It's some bullshit. It like processes this CSV file. I have it split up into a bunch of really stupid functions. XKCD, let's see what you've got for me today. Switch it back. I spend a lot of time on this task. I should write a program automating it. Work on original task takes this amount of time. Writing code takes a lot more time. Automation takes over free time. Hurrah! Writing code, debugging, rethinking, ongoing development, no time for original task. This is true. This is very true. But I'm having fun. And that's what really matters. Anywho. Yeah, so next session, we are going to be talking more about IP routing algorithms. So tune in for that on Tuesday. And then tomorrow, we're going to be doing more D&D bullshit. Specifically, I am planning on working on... What am I going to be working on? I did write out a list. Yeah, on Friday, I'm planning on working on some NPC design, specifically PCs who could be friendly or hostile, depending on how the players wind up interacting with them. So that'll be what I'm doing on Friday. Tune in tonight for Primordium. We are going to be reading the love song of J. Alfred Prufrock, and trying to analyze it with some different lenses than we did last time. I'm personally going to try to analyze it with a horror lens, because I think that could be fun. Like a gothic romantic lens. And yeah. Catch y'all later, nerds. And I'll see you at 6:30, 6 p.m. ET if you are planning on joining in for Primordium tonight. Otherwise, catch you tomorrow. Bye. Oh no, where's the button? Okay, bye.